The scenes being televised go through the camera lens.
In government schools all over the country, such workers trained for jobs of vital
are called machine
Day and
tools.
night classes are conducted.
Thousands of things we use every day are made with them. Or they are used in making other machines that make bicycles, electric motors, gasoline engines. In fact, most of the necessities and comforts of our modern life. Although machine tools work on metal, they have a familiar cousin in the world of
And so the only way to mitigate that is to ensure
With every man utilized, we are still short millions of pounds. We must call upon women. At first, women go into service jobs, releasing men for the army and for war industry. Out of 50 million women at the beginning of the war, 10 million were working. In war towns all over the United States, women are called upon to leave their homes and take jobs. Among our young unmarried and among older women,
one of the primary things during that test is to establish what the emissions both gases and particulates the engine is putting out. And from that evaluation, a ventilation rate is established to provide the necessary health protection for minors.
They undertake efforts
laboratory, we can test diesel engines over the entire operating conditions that the engine will see in a mine environment, and we can simulate a variety of altitudes that the diesel engine could potentially be used in a mine. The approval process also involves testing one of these engines in a laboratory condition where it's instrumented to measure the gas emissions, the smell exhaust. It's be instrumented for surface temperature that we get from this engine. We measure all of the performance parameters to verify that the engine is specified as actually how it performs. The engine that's submitted for approval is an engine that is representative of all the engines of that particular model. The engine is operated throughout its operation. A range to determine what's the maximum CO level and maximum NOx that the engine will produce, to establish what the maximum fuel-air ratio for that engine should be. And from that evaluation, a ventilation rate is established to provide the necessary health protection for miners.
All the incineration is collected as far as the test data and all the drawings, all the pertinent drawings for that particular engine are processed and put into the package, and then a certification or approval is awarded to the manufacturer for that particular model engine.
When an engine or a machine with an engine arrives at your mine, you have to make sure that engine is properly adjusted for your altitude. And an authorized representative of the engine manufacturer has that information, and they can make those necessary adjustments. So deration means you have to cut back the fuel to match the available air. So you're going to lose power even if you didn't make adjustments. If you adjust the fuel to the altitude, you're going to operate the engine much more efficiently. And you're going to lose some horsepower, but you're not going to produce excessive CO and particulate matter and smoke. So as you go up in altitude, you have to cut back on your fuel to keep that ratio between fuel and air the same. So the emissions which a miner experiences at a low elevation, providing him with the necessary protection needed for health, that emission level of both gases and particulate remains the same for a miner operating at a higher altitude.
We'll have to learn to live with the
molecules have not been improved on or controlled by science. They are untamed and unruly.
For a little bit of time,
next actually takes place in about 1/500th of a second.
And any time that you take a machine that's 150 horsepower and incubate it
the spark
at
ignites
this
the
elevation,
compressed fuel
you're getting down in the upper 70s to 80 horsepower.
Watch for the knob.
It's pretty tough to make that machine where it's still a viable machine. At first there was a,
combustion was uneven and uncontrolled. and at the end there was a jarring, violent explosion, a knock that pounded and shook the engine. Now we shall repeat the action.
Cut off to it right now, and they said we can still perform work with this vehicle, and they learned how to make it perform.
Watch
and I think
again
that was
for
the
the
key. Is the operators would find out what they needed to do to get the same performance out of the vehicle, and they could do that.
When you go to that fuel
Now,
rack setting
with gasoline
that's
made up of
mandated
molecules that have
by
been
the regulations,
science-fashioned so that
it
they
really
have the
makes the
required
machines
anti-knock quality,
it derates them to the
molecules
point
that
where
stay under
they won't
control
do the
and
work
work as
that
a
we need.
team.
So we've had to find
Let's
other
see what
ways
happens.
to compensate for that. For example, on our IMCO trucks, we've installed superchargers.
Note in this case that the
And
combustion
of course,
is more uniform.
we're able to bring
and there is no
some of that
knock.
power back and again have
The
a
big
machine that
difference,
will
as you can
accomplish
see, is that
what we
with
need
gasoline of
to
the
have done.
required anti-knock quality, there is no knock.
Adjust
Combustion is smooth and
ratios
even.
on
It's
diesel
completely
engines
under
will
control.
sacrifice power and horsepower.
Now we shall repeat the action.
But
Watch
that's
how the
something we can deal
combustion
with
proceeds as it should,
with
smoothly and without
gearing
the
and
interference caused by knocking.
gear ratios and that kind of thing. And it's something we're willing
In the
to
modern
do.
high-compression engine, modern gasoline gives the greater performance required today.
We try to
The
take
car accelerates
this
more
fleet of
rapidly, climbs
320
hills faster,
vehicles
travels more
and
miles per
make them
gallon.
run
In addition
as
to fashioning the
efficient as
molecules to
possible.
prevent fuel knock,
And that's not
refineries
just
usually add
including
minute
emissions.
quantities of
What we do,
tetraethyl
what we
lead
look
to help
at
accomplish the same
is
purpose.
the best emissions
This
we
model
can get,
shows how
with
just
the
the right amount of
absolute
fluid
amount of power we
containing
can get on the
tetraethyl lead
job
and dye
and
is
get our
added
best
to the
fuel
gasoline.
economy on the vehicle, longest engine life, things like this. It's all tied together, and we monitor this with the diesel emissions output from our weekly tests. We didn't know what this
In the knock testing
Our
laboratories,
fleet average
test
at that
engines
time,
are used to make
first
sure
we
that the
could,
proper anti-knock
the
quality
testing
has been built into
in
Standard Oil's
97 was
gasoline.
1,597
The high
parts per
anti-knock
million
reference
CO,
fuel is called
997
isooctane,
NOx.
hence the expression
As far as
octane
maintaining
number.
the
This test
equipment
engine is
and
equipped
that
with a
before you
dial
start, I
indicator
would do
that
all
shows
the
just how
pre-ops,
badly the engine is knocking.
drain and flush
With
your
a fuel
scrubber,
of
make
low
sure your
octane
scrubber
number,
shuts down,
here's
runs
how
out
it
of water.
sounds.
Check your fillers,
Switching to a high
your
octane
intake
number of
manifold, all
fuel,
that
the
for
knocking
leaks.
diminishes
And
and
just
finally fades out
wash,
completely.
clean it up. You know, if you got a problem, fix it.
If my CL level drops, the first thing I would check would be my flame arrestor.
This illustrates
Until-
the smooth, even performance you get
That
from
didn't
standard
check,
red crown
then
and
we'll
standard
go a
white
lot
crown.
deeper.
If you see an increase, if it's substantial
Engineers had
increase
his
in
say,
CO,
but modern
that
processes and
equipment needs
skillful
to be pulled
know-how
out
are
of
not
service,
enough.
and
must
there
also
needs to
be
be some checks
safeguards.
made to see why. Everything that's on the checklist that we go through is right out of the manufacturer's manual. You name it, we check it.
Okay, we make sure the engine will shut down, the emergency shut down. We check the gaps on the light, oil level check, fuel leak, accumulations on the machine, tires, lug nuts, parts brake. We've got a checklist we have to go down.
We've checked the emissions end of the machine. We've checked basically the whole machine.
Another to
Top
make
to
sure
bottom
that
to make sure
today's
that it's
fine
maintained right.
gasolines will not deteriorate
The
in
weekly
storage.
examination takes in the gas emissions part plus
A test
the
that guards
permissibility
against
safety part.
corrosive
of it.
The
impurities.
baseline we're using now started in January, so we have the emission samples from every week this year,
Testing,
and we have an average that gives us a baseline. If our weekly
another
CO
of the
is 20%
1,500
above
and
our
more daily
baseline,
control
we will
tests.
take immediate action to find out why. Right now, our CO average is 230 parts per million
In
CO.
addition, these great laboratories are
Since we
entirely
started
devoted to
doing
extensive research.
weekly tests, I've noticed a big improvement on the upkeep of our equipment and a very big improvement in the
Carried on by
emissions
hundreds of
output
capable
of our
scientists
equipment.
working
the
on
same
more and
people
still
doing
better
the
products
tests every week.
for the future.
You don't have to specify the same guy per piece of equipment, but you need the same people doing this consistently every week. The output on the diesel emissions is going to tell you a lot more on the operation of that engine than anything else. What's the engine temperature? What's the exhaust gas temperature? We're going to be here before we stamp the test.
Cooperative work
That's
with the
going to
automobile
get
industry
consistency. And when we start
guarantees
getting
that the right
consistency,
gasoline will
that's when you
always
can
be
make all the
available
numbers
for any
go
car
down.
that's developed.
I have engines right now that are running 8 to 12,000 hours a day.
and you have
And
what
the
it
weekly
takes to
emissions
deliver
on them
today's and
are
tomorrow's
almost
great
identical
fuel.
to the day they were born.
Build units like the
Now, in
superfractionator
1997,
and
our
the other
average
multi-million-dollar
engine
units
in a
that go to make
permissible
up the great
application
modern
was
refineries of
rebuilt
the Standard
between
Oil Company,
3,000 and
Indiana.
3,500.
With the tradition of
Our
pioneers
engines now
behind
are
us
going
and
8
better
to
facilities ahead of
12,000.
us,
You know, we
future
clean the air
progress
up
leading
better.
to
It
still
would do better
finer
all the way
products
around for
is
everybody.
assured.
The pollutants are going to be
So
cleaned
there's the
up.
story,
The
folks.
mine environment
I'm
in
proud
this
to be a
mine
part
has
of it,
improved
even
greatly
if
the last
only as a
couple of
tiny
years.
atom
No doubt about
inside
it.
modern
The emissions
gasoline.
are a lot cleaner than what they used to be.
The atmosphere is definitely a lot cleaner and a lot better than it was 20 years ago when I
This is
first
what's
started
behind
in
the
there.
gasoline
Help
you
keep
sell.
people living longer.
It certainly
from
does
tank
clean
truck
up the air and it makes us
or
a healthier
service
place for our
station
people to
driver.
work.
You know, I think we have a cleaner
Behind these
environment
symbols of
underground,
service
and we want
is a great
that.
record of
clean
scientific
running machine
achievement
is
that
always
certifies
better.
You know, all
today's
the guys
leadership
underground,
and
you know, I like to
guarantees
consider them
tomorrow's.
and you want to provide them with the best atmosphere you can.
Hopefully this program will eventually get us there. I don't think we're there yet, and I think we've got a long ways to go as an industry as well as a company. But the ultimate objective, of course, is just to get ourselves to a point where our employees are working in the safest environment we can provide.
All engines must be approved, and it's important to maintain established ventilation rates. An authorized representative will derate your engines for your mine's altitude. Engines should be properly adjusted and maintained. Conduct weekly emissions tests to establish a baseline for each piece of equipment, and maintain consistency for your testing program. For more information, go to www.msha.gov.
This happens because the current flowing through the tether creates its own magnetic field. The new field interacts with the Earth's magnetic field and produces an opposition force. This acts as a drag on the tether system and causes our orbit to decay. If we were to generate electricity for a long period of time, we would have to fire the shuttle's jets to increase our altitude back to its original position. The same would be true if we were a space station generating electricity with a tethered system. Eventually, our orbit would decrease and we would have to boost our station back to a higher orbit.
That's where the tether comes in. We can turn our giant electric generator into a giant electric motor and use the power to increase our orbit. Here's how.
First, we must understand that electric generators take mechanical energy and turn it into electrical energy, which means we put motion in and get electrical energy out. But now let's remove the light bulb and replace it with a propeller, and put a battery where the crank was. Now we're using electrical energy to create mechanical energy. On a space station, we could possibly drive current through the tether against the direction the magnetic field wants to make it flow. When current flows in a reverse direction, so does the force, meaning our drag is now a thrust.
By turning the space station and tether into a giant electric motor, we can increase its speed. This will increase its altitude without having to fire thruster rockets. This is only one of the ways that electrical energy generated by tethered systems can be used. Can you think of other ways?
The dynamics of the tethered satellite may seem complicated at first, but they're really just variations on concepts you already study in school. Things like amps, volts, resistance, magnetism, and mass. With an understanding of these basic principles of physics and a little work, there's no limit to what you can achieve in space or on Earth.
Hello, I'm Franklin Chang Diaz. As a scientist as well as an astronaut, the opportunity to take part in the tethered satellite mission was a special treat. During our flight, however, we were reminded of how scientific research doesn't always proceed according to plan. Some of you may know that after 5 hours of deployment operations, the tether broke free from the shuttle. It was a clean break at the tether boom, leaving no loose tether near the shuttle. we quickly saw that we were in no danger of becoming entangled. There was an initial recoil at the loose end, and then the entire system, all 19.7 kilometers of it, moved rapidly away from us. Later on, when we inspected the end of the tether that remained attached to the boom, we noticed that it appeared burned or charred. And when we saw this, we thought about the possibility that the high voltage we were generating and a failure of the insulator material had caused an electrical arc which was powerful enough to burn through the cable. After several months of examining the data and equipment that we brought back to Earth after our mission, an investigative panel concluded that our initial suspicions were correct. Now you will soon learn that the power generated is the product of the voltage times the current. Similarly to what happens in our light bulb filament, in an electrical arc, the power ends up mostly as heat. Now the fact that we generated 3 times as much current with the tether during our experiment as we had expected effectively tripled the power generated and also the damage to the cable. Even though we lost the satellite after 5 hours of operations, during that time we were able to prove the electrodynamic tether concept. In this sense, our mission was a scientific success. Information we gathered is teaching us that our present understanding of how electrically charged bodies behave while moving in the ionosphere must be modified. Our scientific team is already busy using this information to build new models to predict this behavior more accurately, and someday their findings will be taught in schools. The tether satellite has also taught us that engineers who build electrodynamic tethers in the future must carefully examine how to design high voltage equipment capable of operating in the space environment without arcing. Findings like these are how scientific progress is made. And so our mission of discovery did just that, bringing in a real bounty of new and unexpected knowledge. STS-75 stands as a reminder that in scientific research, nothing is guaranteed, and even mishaps can provide valuable learning.